Good day, folks. I ran across some old documents here. This was actually a report I have in my hands here. Very lengthy, but one long story short, it's a 1977 report of an apparatus to rectify what they call as ether energy. So, to try and summarize it, it goes really deep into the original Tesla technologies. And basically, it's just a review to start with, how Tesla did his things and how he could get communications of 200 miles and to understand his instrumentation. Nothing new, really, up to this point. And then we get to the preface here, which is again more of, it's a lot of fluff, I have to tell you. This is all about humanity, being aware of different form of energies and how we should be able to determine the needs, blah, blah, blah. So again, nothing very informative at this point. And then we get to the second part here, which is the apparatus to rectify the ether energy, okay? Another big lengthy document, which is basically some Tom Bearden here, which explains, how a cubic centimeter could have all of this, what he calls vacuum energy. So, and don't mind my dog, please. She's deciding to be really crazy all of a sudden. She wants to be the star of the show. Anyways, as I was saying, nothing really relevant to the device, but we've got pages here so far of just fluff, and I'm trying to find, some real technical information here. And it's not until like halfway into the document, there's a letter here, August 31st, 1978, that seems to give us some hints of what was going on here, okay? So he claimed with this device he was able to get about half an amp and run a light that's about 1.25 watts. It's all here, okay? And they're making more of the points here as you go into the document that that's about as good as they were getting, and voltage about 2.5 volts, okay? So even then, this wasn't really that powerful. But we have to remember that this is dated November 15 to 16, 1977. So in 1977, we have to remember there was a lot of shortwave going on in HF. This was the primary domain of communications. And back then, you still had the big tubes and the big serious power, and the RF wasn't as tuned as it was today. A lot of power went into the ground, so what I'm saying is AM stations basically created a lot of scalar waves in the beginning because the systems weren't really optimized. And what I'm trying to get at, because I'm a ham operator, those will probably understand what I'm talking about is reflected power, high SWR. That creates a standing wave of opposite phase going back into the ground, essentially, of big AM stations, and then you get the scalar potential. Anyways, there was a lot of that going on in the 70s for sure, okay? So all you have to do is build basically a meaty Tesla coil and rectify that, and you're going to get pretty close to that energy. And I've done experiments myself with that, just like a 3 or 4 feet loop. Just use a GE diode, and pretty well anywhere I'll get at close to 100 milliwatts, maybe 200 milliamps. If I happen to be like next to a radio tower or something, that could go up to like 2, 3 volts. Hardly light up a LED, but the point is, it's almost like these people here who were doing the research didn't understand what ambient energy was, and they're trying to, not saying that the ether isn't real. We have a new ether now, a new model of the ether, but these people were trying to suggest that this is the old ether without understanding at all how wireless coupling works, even the environment. We talk about the golden ratio as well. So there are natural frequencies such as the Schumann resonance and the harmonics of that, especially in the shortwave bands in the 1970s, that of course, if you throw an LC circuit in that super excited state, it will kind of act like an electron sucker, and because it's in a super heightened state. So it was So what I'm getting at, this is how I was able to extract some wattage, what they're saying, 2, 3 watts. Then we go on to find the circuit diagram of this device here, which I will show you right here, okay? Seems like a typical atmospheric RF collector, right? I don't see anything magic in this. And if you look at the schematic diagram, you see, a dual coil system, more like L1, L2, and L3 here. You see that? And when I saw the placement as a ham operator, what kind of resonated to me is how these two coils here kind of look like a J-pole system, an antenna, right? Where this is the main one, and here's your arm, and then the capacitor, which is your gamma match. So this to me reminds me like basically a shortwave version of a fancy J-pole antenna. But we'll go on to the next pages here to see how the device actually looks like. This is very blurry because this is really old, but this is the guy holding the... And look at that, right? It almost does look... Now we'll get a better circuit diagram. You could really see it here, what I mean by a J-pole. And this is how, it would look like. You got the capacitor at the top, and then the coil here, and then another coil there, and then all the windings around, right? So to me, this looks like a very fancy LC circuit. Nothing special, folks, but really fancy in the design, as in it resonates at low frequency and has a lot of self-capacitance. Very similar to the coil I built, where when I said I just connected it, but in my case I saw a couple volts as well. So it lines up with that, and in our day and age, even without all of that extra RF that he had to work with, we can have a much simpler apparatus that will do exactly the same thing without, these 15 pages of fluff trying to convince us of this space. They call it space energy. Never heard of that term before, but if you're trying to study it, you're going to get it all wrong, because they have no clue what they're talking about, but they have a good receiver essentially. So here's another article, the space energy receiver. Oh boy. They talk about 0 point and Tesla, but without actually going into the details on how it would be applicable with the device. Space energy power system, villages in space, and these are really going into the science fiction. But again, we're looking at this here, and it really made me think, because it does line up with some of the devices I built. But perhaps, and then I look at this. This is getting a little bit into the esoteric, because it talks about the tuning device, which is a crystal and a cavity and the capacitor. Basically, one long story short is this was the control device which would initiate the feedback. Now, in today's age, there's much more efficient ways to do this, and I figured it out, and I will share with you basically my corrections and my revisions to this device here. And these are just emails, recent emails in the news groups of people who have tried replicating it exactly as is in today's world, right? And for some reason they have a hard time getting it to work. See, I'm getting some comments here, 138 milliamps and down to 0 after 10 to 15 seconds of a load. See, the people are seeing something, but as soon as they try and use it, it goes away. Another person says, he's getting 80 millivolts and considers using earth batteries instead, because even though this thing works, it's pretty well, in his eyes, not very efficient. Well, of course not, folks, because this was designed for shortwave in the 1970s. It's tuned to resonate with low frequencies. If you don't provide that trigger, the system won't be able to couple properly, but it will still act as a lousy inducer and give you that 80 millivolts or so. So again, this lines up with everything I know based on what I've read, but their device, if you want to replicate this in today's world, will not work properly, okay? So it got me thinking, and I figured out a way we can build this that will work very well in today's world. So just stand by for part two because there's a lot to cover here. Because I have to show you how I got with the ideas, because you won't understand it from the circuit diagram, because I had to actually modify certain semiconductors, and I'll get right into that. Alright folks, so when we work with any kind of over unity system, electronics anyways, what seems to be the common parts when we have to make this work? And basically it's breaking the symmetry, having nonlinear. So diodes, as some have specified, is usually one of the components that is relatively static. With all these energy experiments, you need to have that diode in there. Now, of course, the diode, as great as it is, depending on what kind you're going to have a greater forward voltage, or it won't respond to certain frequencies and will respond better to others, you see. That's the issue with diodes. And for a while, I was doing just like Bedini and going around the backyard and finding any kind of random stones. I had a little plate like an old-time crystal radio where the plate had a one kind of metal that I clip on, and then I'd have the cat whisker, which was another type of metal, and I'd basically probe any kind of rock for random p-junctions. So every time you find a p-junction, like Bedini stated, you get different results in the spectrum. It doesn't, it's not a linear like a semiconductor, so you can find interesting, frequency response to cosmic waves, let's just say. However, with my experimentation, as good as it works with random stones, without doing anything more to them, it's nothing anywhere close to what even the regular GE diode is going to give you. So that pretty well threw that idea out of the way. But I did experiment with it to see somehow if I could have like a stone that basically has zero forward voltage, low loss, that does the same thing, right? But I wasn't able to find that. And I kept moving on with experimenting. And I've realized, and a lot of you may already know this, but the transistor could actually be a diode if you short out, like an NPN transistor, if you short out the base with the emitter. And before I proceed, I want to show you my observations with this. So I'm going to show you a photo here, and as you can see from this picture, this is basically a regular GE diode. I was testing it on my scope and I gave it a pulse. I'm testing high frequency here, and I notice it responds, but it gives me kind of like the half, and then you have the wave, and then it sort of plateaus. I show you in the picture there, it gives you like that flat cap for a little while, and then it's like a little flat mountain, right? And it keeps doing that. But what I noticed is when I used the transistor instead as a diode, all of a sudden I got much less, almost zero forward voltage loss. So the amplitude went up right away. I'm showing you this in the chart too. And what it did is, instead of having that little flat mountain at the top, I'm getting really triangular peaks there. So it's a very sharp. So not only does the transistor less loss acts like a diode, but it responds much better at high frequency as well without the losses, and does exactly what I was trying to get. So it's like, oh my goodness, I finally found the method that I need to use the diode as a diode, but without all those traditional losses, and making it work on better frequencies. So as you can see in the diagram, after I found this out, I decided to incorporate this in this radiant energy device, and I will show you how it works. All right, let me explain to you folks that the energy today that's in the ambient, a lot of it that's artificially produced anyways is more high frequency. We're pretty well faded away from the shortwave days. So by that, even your taxi drivers, your police departments, most of that stuff all operates on the 800 megahertz or more. Some of it isn't very high power, maybe just 50 watts, but that's where basically it's all at. And then you get your cell phones and your Wi-Fi, that's into the 2 gigahertz and 5 gigahertz. So we're a much higher frequency society than we were in the 1970s. So to take that into consideration, I wanted to build, as you can see, a loop antenna because as a ham operator, I've used to work with magnetic loops and they're very interesting devices. So I decided let's use the transistor diodes. So don't get confused. These diode symbols on the diagram are actually the transistors configured as diodes. I reasoned to use the actual legs, which is a few, you know, an inch or so to build the loop. So you're probably going to need a couple hundred transistors and capacitors to make this work. Maybe supported in a small plastic tube as a loop would be a good starting point. I even thought of maybe making it better by finding the thinnest copper tubing and maybe cutting an inch in between every stage to make that essentially a more resonant device. So what happens here, we have diodes, okay? So, and also essentially a crude voltage multiplier circuit. So there's a capacitor. I didn't draw it in the schematic because it was too complicated with the room and everything. But as you see there, there'd be a capacitor in between every transistor diode. And this forms the crude voltage multiplier circuit here. So what happens is because of the configuration of the loop, as you see, it's an induction device, but multiple wavelengths because each stage sees a little different dimension because the diode blocks it. So in essence, it allows you to tune different wavelengths at the same time while multiplying that voltage. Now, I reasoned that to make it simple, we could use a reed switch, and what we're going to do is, you know how MOSFETs work, you know, they turn off with, you know, so I figured the reed can do that too if you buy the reed switch, which is normally on and turns off when it gets triggered, right? So what I'm getting at is off switching is better for this kind of radiant energy because it uses less. So with that said, to experiment, the reed is easier, but once you get the hang of it, I'm sure you'd want to replace this with a MOSFET, okay? But the reed is good to start. So as you follow the arrow where the current goes, the power, it goes through because it's normally open. So we have a coil, which is a transformer in line here. So what's going to happen is once the voltage gets multiplied to the trigger of the reed, it closes. So that creates that sudden surge, right? That back EMF we all love, remember, folks? That gets set into the transformer, coupled into the feedback loop, which will send that concentrated spike back into the system for additional inducing to create more feedback. It essentially keeps the coil triggered in a hyperactive sensitivity state, so to speak. And then next to it, you have the coupling loop, which just passively couples and rectifies that into your load. Now running it in this configuration solves the problem of today. And here in the comments that I was reading in this device where people, you know, as soon as, you know, you have a diode, you need the diode, but as soon as you touch the diode, you lose the resonance, the dampening starts, and, you know, they have 80 milliamps, 80 millivolts to start, and after 2-3 seconds, it goes to zero. So by configuring that way, your load is not connecting directly into the device that's doing the feedback. So we're not subjecting it to that dampening we'd get if we were to just connect hot off a diode and then the whole LC oscillation would just go, right? That's what we want to avoid. So by keeping it very passive this way, and I guarantee you this concept works. I've experimented with it myself on a small scale. I mean, if you're very serious about this, I don't have the money, but guess what? If somebody wants to send me a couple hundred transistors and little copper pipes and everything, I'll build it for you, okay? But my point is, if you're interested in radiant energy and you've already looked at this device here, and you know, all the theory unfortunately is all wrong. They don't know what they were talking about at the time, but the concept currently works as, you know, a magnetic loop. I just modernized the idea and took advantage of semiconductors and what I know from what I've learned to make this work. So with my corrections, if you're serious and you follow this, obviously dimensions, values, and whatnot, you'll have to experiment. But you know, the point is, if I could get, I'm in the middle of nowhere and no big high power, and if I just take a little like 5 feet wire and put it on a GE diode and put my meter on there, I read somewhere around 100 millivolts. Can't do anything with it, but it's there, folks. So if you can multiply that enough to a few volts to trigger a read, or a MOSFET to close it down, you get the back EMF action, and this is what we want. Let the cycle repeat itself automatically and let it trigger by the environment. So again, let me know what you all think, and I hope this is useful for anyone who is into this kind of research.